Okay, I'm not sure I understand the question. I mean, so I guess, I mean,
Okay, we good? Awesome. So we have now Matteo from Matter Labs, who presented the paper and was accepted at ZKProof 6. Any paper that starts with "would it be cool" is automatically accepted to ZKProof 6, but his was accepted on merits because it's actually cool.
All right, good. Thank you.
Go ahead.
Hi, everybody. I'm a cryptography researcher at Matter Labs. Credits to Marco, who co-authored the paper with me for the subtitle. So that's it. So the talk I'm about to give is not a very technical talk. It's more like a philosophical musing on the question, how do we keep our mental sanity as a community if there's this exponential acceleration of constructions and claims and so on and so forth? And so I want you to keep as an image in the back of your head. I do remember modifying the slide a little bit, so I hope this is updated, but it's fine. So this image. If you don't know what L2bit.com is, it's a platform that tracks several parameters, several statistics related to layer 2s, but it also provides a bunch of information about them, so about the risks and so on and so forth. This is just an image and a metaphor we're going to use later. Okay, this talk, so why is it useful to compare zero-knowledge proof, and what do we mean by that? Let me start from a premise. The usual caveat applies here. By zero knowledge, I mean cryptographic arguments. I don't mean, we don't require zero knowledge here. I'm going to show how there was a previous proposal actually presented right here at ZKProof, and so there's no new problem. What's the state of affairs with that right now? The state of affairs may not be very good, and then we can talk about what to do with it. Just as a forward, this is an opinion piece. This is very subjective, just we're coming from a certain angle, and it comes from our understanding of how things are, which may not be accurate. So please come to us if you have better proposal than ours and better beliefs, opinions, information, and so on and so forth. Okay, so how do we usually compare cryptographic arguments, right? So one classical tool we use is we have very, very descriptive tables with some level of efficiency parameters. So in the last few years, a few years ago, there would be all asymptotic O's right there, but now we use concrete numbers, right? So in that sense, we got better. But this is still very far from a good comparison. Good comparisons usually see what happens in practice in terms of communication complexity, proving time, verification time, RAM usage, and so on and so forth. And we know it's all very messy. Other types of comparison that we care about in this context are, of course, security. So ignore, I borrowed this slide from Sarah, Michael John, so ignore the caption in the middle. What's important here are the assumptions on the left, which are useful for understanding the security of different arguments. But we could go farther than that, right? So if you say, well, my cryptographic argument relies on the security of a certain hash function, it matters how you're instantiating the hash function, right? It matters in what curve you're working in. So that's a type of comparison security assessment we're interested in here. So okay, so as a working definition of comparison and assessment of cryptographic arguments here, I mean, we compare blueprints, so think of your description of the argument in your favorite paper or well-written white paper, and let's also think about artifacts. We care about concrete, deployable, semi-deployable constructions here. And then what we're going to look at, we could think roughly of efficiency measures and security assumptions, okay? Both in concrete and abstract terms. Fine. So I want to stress that here I want to push the need for comparing zero-knowledge proof systems, but I want to compare them at a glance in a way that's feasible. So I don't just care about the feasibility of the comparison, I care about the efficiency of the comparison. And why is it, who will care to compare things efficiently? Well, clearly researchers, they want to compare designs to existing ones. They don't want to go crazy finding ways to do that. They need to critically assess claims of published and submitted works. Practitioners want to know what to use in their product. And consumers want to understand, want to have beliefs about who's best at what. And they need to have an idea about that too. And so this is having a way to compare proof systems is particularly important if you have such an accelerating expanding area, such as, for example, rollups. All right, and somebody else already pointed out this is a hard problem. They didn't come exactly from the same angle, but they pointed out that if you wanted to do something like this, there would be many challenges. And this is the community proposal at the third Zero Knowledge Proof workshop. I invite you to check out the meeting notes from then. Some of you who are here maybe were there at the time. And so we are sort of orthogonal with that proposal, but I would like to talk about some of the good observations that came out of that. All right, so for example, this is a slide from their presentation, and they identify 4 sets of challenges. Suppose you want to compare proof systems. This is a problem we also have in publishing, right? So what are good circuits, functionalities you're going to compare them on? How do you choose them? And then design flexibility, right? So do you compare an optimized version versus a non-optimized version? You compare scalability. You want to see how the curve looks like as you increase the input size, or do you care about specific ones? Do you have an underlying environment that's a very powerful CPUs, a cluster of CPUs? The complexity is mind-boggling, right? So I mentioned some of the features of this. And then the paper, the proposal keeps going and proposes, for example, ways to do that in a scalable way. So for example, says, well, it'd be great if we had a benchmarking tool. So you have your proof system, you plug it into an API, and the API runs it on tests and tells me how long it took for doing X, Y, and Z. Nice. I mean, this is all very good. And then there was a companion proposal, ZK interface, which you can think of as a layer that should uniformize different intermediate representations for different libraries for snacks. Great. So that was 2020, and then what happened? And my understanding is that not much happened, unfortunately. So I invite you to challenge this belief afterwards during the question. But talking to some of the authors, it's John is challenging, Ray. Go ahead.
So it's not a real challenge, it's adding information to,
go for it, yeah.
to your talk. So ZK interface that you've seen here was actually picked up by a DARPA project of $100 million and was used to coordinate between 15 different teams doing front-end and back-end. There were iterations on it, which resulted in something called IR1, which is an internal evolution of ZK interface. And I'm actually happy to tell that IR1 has been released by DARPA to come back to ZKProof with all of their iterations. So we're going to get back ZK interface evolution.
Sounds good.
And have it as a useful representation here. All of this was kind of not very transparent because it was like a defense program that had to be released to open source. So it's not surprising that it's not widely known, and it's very recent.
Okay, no, sounds good, and that's excellent news. At the same time, so in the rest of the talk, I'm going to argue that even if some of the technical problems are solved, there are more non-technical decisions the community needs to make to move forward. So, okay, yeah, my proof that not much happened was, for example, a screenshot with the last commit. I couldn't see much public work on this. But anyway, so it brings us to today, and I want to do a little interlude saying why I want to keep banging on the point that things could go insane at some point. And so what we've seen the last 4 years is way more adoptions, so way more projects using cryptographic arguments, layer 1, layer 2, sorry, marketplaces in layer 2, and new constructions, right? So here I've run a tool I wrote some time ago, Citrus, which you can think of as a way to offline get ePrint and cryptographic conferences stuff. Check it out if you want. And this is the screenshot of, this is a lower bound on all the constructions. Just look up snarks for 2020 cryptographic papers, 2021, 2022, and so on and so forth. You can extrapolate from that. Right, so I can get now to the Toulon TLDR, this proposal, which is call to arms. Let's have a system process that, let's have it, that allows us to compare cryptographic arguments at a glance. I swear I didn't coordinate with another presentation by Ben today. They also used the call to arms image. So the other point I want to make is that it's obvious, I think, it's pretty plausible that the ideal result is unfeasible. Any ideal result would be very hard to achieve. I still would like to submit to you that we should at least head towards some image of an ideal goal, while having something imperfect but good enough in the meantime. OK, that said, suppose you want to try and answer that question. So what is this going to look like, this something I mentioned, right? So let's first analyze what we agreed so far on. We have a vague goal. We want to have this system process and so on. And I propose a vague notion of comparison, right? So we can, of course, sharpen them. Let's sharpen them. So let's start from a question. A critical question is, how do we already assess cryptographic arguments today? So what's available to assess them, and how do we do that? And here, I would like to make a sort of distinction, and I want to suggest that there is a divide between how academia does that, and there's certain strengths and weaknesses, how what I'm calling quote-unquote industry here is doing that. So from the academic constructions, we see, published papers that usually require explicit security claims and explicit security proofs with explicit constructions. And they're peer-reviewed in the ideal world, properly peer-reviewed by other experts. Often, they lack usable implementation here. They sometimes have implementations, but they're not implementations. They are benchmarking things, or they're not usable for many other reasons. So they're not easy to benchmark. They're not easy to plug in other ways and such. So on the other hand, we have many constructions that are usable in practice. They're applied in many settings from the industry. They tend to be highly optimized. That's great. So you don't just get the proof system. You get the proof system at its best, right? So we don't know. Compare, I don't know what the numbers are now. A few years back, Falcon implementation growth 16 versus other implementation growth 16. Big divide. But they tend to be described usually informally in white papers. Sometimes they're not described. You don't know what's happening. And as a consequence, it's hard to peer review them, and they're not peer reviewed. And it's fine. I mean, I'm not saying, I'm observing these as limitations, but I'm not saying it should be, I'm not saying that every academic construction should have a usable implementation. I'm not saying I want to improve things, but so I'm going to observe these weaknesses. And then, I mean, the industry relies on security audits, which is great. Sometimes, I'm not saying it always like that, these security audits are performed by people who are not experts in zero-knowledge proofs or in cryptographic arguments. So it's plausible to think that this could have a dubious effectiveness, right? OK. How does this inform us? So I claim that this could inform us in two ways. So goal-wise, I think the goal of having assessments and comparison and heading towards something should try and bridge this gap, because many constructions come from academia, but they are done practical, concrete, sharp from the other world. And so this gap should be bridged as a consequence. And it could also inform us approach-wise. So to find this process, let's try and meet in the middle. Let's try and use the strengths of both camps. And the shape of the ideal goal would be a little bit like this. So I want to have something to look at and towards which I want to head, right? It's going to look like this, whatever it means on the surface. But there's going to be something keeping it afloat, what we need to do to make it work. So let me give our proposal. It's just a proposal again. Take this intuition about the tip of the iceberg. And it's this, an L2 bit for ZKPs. This is just an analogy. The analogy breaks very easily, but So what I mean here is let's have some way to homogeneously gather information about zero-knowledge proof assessments and some type of interface for it that helps humans digest it. In other words, keep in mind, for example, the L2-bit interface I had before, and let's dream of something that looks like this. I don't know, like there are just two proof systems here. This is just me playing with HTML. Bujumera, the proof system underlines ZK-sync, for example. Imagine having a brief summary of how it works. You can click on things and you get reviews, descriptions, informals by other people. You have their names, risks, and assumptions. So you know instantiations of hashes, assumptions, claim security in terms of bits of security, for example, efficiency profile for some definition, and maturity for some definition, whatever that means. We can decide what these columns are and how they are defined. But it's good to have some format to this type. And again, this goes back to the working definition we had of comparison. So it's a comparison between a pair, not just a construction, but something more concrete than that. And it's comparing in terms of efficiency and security and so on and so forth. OK, so if that's the tip of the iceberg, how do you even put information there, right? So, and there could be different ways we could agree on that. What are the requirements for any process? Maybe, for example, it should be lean. We don't want it to be a standardization process. We don't want to wait 10 years to say, we don't want, if Gross 16 came out tomorrow, we'd like Gross 16 to be there the day after tomorrow, maybe, right? So we don't want to wait 8 years for standardizing it. It should be lean, but it should be an assessment. We want some type of reliable information there. Should incentivize participation. So there should be some intuition by which you want to be there. You want your proof system to be there. People should trust this system infrastructure. It should bridge the gap I mentioned before. And so the proposal for such a process I'm going to make is let's run it sort of like a lean conference. Let's make people submit entries. These entries are specs and artifacts. Let's have them peer-reviewed. Let's do that often, so frequent rolling deadlines will not, like some conferences do. So what I just said, so imagine this. So you write your paper, your construction, or no, let's make a ZK-sync related example. So Matteo Labs pushes a white paper describing the specs of their proof system, security claims, instantiations, code, ways for reviewers to judge everything and then do measurements. And then there are reviews and some type of assessment of the information, like the information in the image. So how's this different from an academic conference? Well, it's got completely different, a little bit different requirements. So with respect to formality, related work, we're not going to require the same things. We don't care necessarily about novelty. There's more stress on artifacts. This should be sort of a living creature, right? We can accept resubmissions, incremental changes, as long as they're documented. And it should be good to, have a sort of graph on interdependency. If I know that KZG, if I have something like KZG or hierarchs in there, and Jolt uses hierarchs, that simplifies things a lot. OK, but why would this even work? Why would anyone jump in, right? So the only intuition I have for how this could work, I was really scared that even if you could answer, you could gather people and motivation and some type of feasible ways of approaching this. Why would anyone jump in and have their proof system there? Well, I think the intuition I have is that for visibility. And the intuition I have is this. So if you have an infrastructure where whatever it's called, that is the place to be, then people will try to be there. So if you can bootstrap this properly, if key players, key people, think of this workshop we're in right now, right? So it was bootstrapped from nothing in a proper way, and now we care about being here. So it may be possible to do that. And I'd like to suggest, by the way, as an aside, that maybe a way to do that is that anybody should be able to submit an entry. So not only Jens should be able to submit Gross 16 as an entry there, somebody can do a proper documentation of Gross 16, write their own implementation, and say, hey, of course they should attribute intellectual property, whatever you call it, but they can make an entry of this type. And therefore, this could incentivize people who are the authors to make good entries themselves, for example, to make good code and so on and so forth. That's just a proposal. Again, half-baked ideas. I'm willing to hear your opinions. Who will review this? I mean, it should be a mixture of, so think, of course, people who have the expertise for that, cryptographers, applied crypto experts, cryptographic engineers and such. And it should be a mixture of people. We also want to avoid conflicts of interest. There should be some level of impartiality in all this. But this is lots of detail. So this is the general idea. Some expected questions I'd like to mention. So isn't it a terrible nightmare to fairly compare cryptographic arguments? Because, for example, they could be efficient on setting A, but not setting B. How do you expect those columns to be fair? I don't know. I think it's a very important question. It's absolutely true. We need to have an answer to the question, but we should have a good enough answer and keep moving towards something that works that way, despite that. What if, they have different profiles? One is fastly parallelized but slow otherwise. Same question. I don't have an answer to that. I'm willing to accept good answers, but let's move towards that. What if, isn't it a mess that some are 1CS based? We just heard about IVC and some are ZKVMs. Sure, let's have them all there. Let's find an answer later, and so on. So, OK, I think I would like to submit to you that finding ways to compare cryptographic arguments at a glance is an important and urgent problem. It is hard. It could be like this. So basically, some of the ideas are sketched here, but it could look in any other way. If not this design, then which one? Do you agree that this is an important and urgent problem? How to move there? If this design or any other, how to bootstrap it? And how not to be parallelized by the unavoidable, very rough edges. Thank you.
All right.
First of all, congrats, because I think this is a really interesting talk. And I think this is hugely challenging, as you mentioned. I think we definitely need this, because it's really hard to compare. We actually did a benchmark website a while ago. We didn't touch it since we did it, by the way, which often happens, called ZKBench. But one of the things I think is key that we learned from our experience is that, I think you have to just have an opinionated person who is impartial, who kind of has a final say. And as you said, I think, because actually you can make statistics say anything you want.
Mm-hmm. Yeah.
You can make any benchmark look really, really good or really, really bad. And I think what we tend to see right now is a particular platform or protocol or whatever will come up with a new design, and they'll be really unfair to all the competitors. And then 2 weeks later, the competitors come out, but it's too late, right? Yeah. And so I think you would have to have someone in charge, or a small committee, but they would need to be impartial and not making their own protocols. But that's just my advice. But I think this is a great project, and I really support it.
Thank you.
So well done.
So part of the reason to propose this here was to understand what is interesting for people. Like, for example, the thing we could think of is, let's compare the usual SHA. So you ask everybody to prove SHA. Because right now, I don't know, it's kind of on top of interest for a lot of people. But maybe, I don't know, next year we could say we want to stimulate the competition to do maybe light client-side proving. And so you could say, let's add a benchmark for that, and people will start competing for that to show. So what we're hoping to get is that people want to climb sort of the leaderboard of the website, right. And so whatever you throw at them, they will try to do their best, even if it's not maybe the main goal of that company to work for that topic. So in this way, you can steer a little bit the interest. So the question is, if you have other benchmarks that you care about besides SHA, we will speak up.
We definitely saw people reaching out to us after we launched it, asking on that. Oh. Yeah, we definitely found that. People were definitely interested in adding their own spin on it, and like we had a bunch of people come back. And to I think what you said, and I think kind of where the presentation was going, like you don't actually need to necessarily compare SHA. Like if one protocol has SHA but the other one has Blake, then that's fine, right? Like so it does require a lot of like there was nothing consistent across all of the protocols that we checked, like almost nothing. So yeah.
Not easy.
Yeah, on that topic, I had a quick, like, related anecdote maybe, which is on the MPC side of the house, I think for a number of years it was like, the standard was like who can implement AES the fastest, and you just got a lot of protocols that were really good at doing AES circuits and nothing else. And like, I don't know what the proper metrics are here, but it's definitely something to be careful of.
Right.
Thank you, great talk, and I think something which is very pertinent. Have you thought about like Hugging Face kind of like style of competition where like you submit some problems, you submit your proof system, and then you can like try to have this kind of like iterative and automatic like benchmarking to see whether like, you know, proof systems are more or less suitable for that?
What was the word used before?
Hugging Face, yeah, is what the ML people do.
Yes, right, and you suggested that it should be completely automatic and such.
Well, what my impression is there is that every once in a while they publish a challenge. So usually, you know, in our case, it would be a circuit to be proven, something which is relevant to them, and then researchers or aficionados, I guess, they submit their models, which are then run on their like platform on the back. And then there's a leaderboard. For example, there's a chatbot leaderboard, which has got like all the various ones over there. And then I believe that they incentivize through also monetary incentives. Not sure if that's something, but it seems to be a way to like really get some nice pertinent feedback.
This is interesting because I think as it was mentioned a second ago, so one problem we have is if you're in a non-adaptive setting, so I know what to optimize for. I optimize for whatever metric X, I submit my thing, and then fantastic. However, if things are sort of more volatile and more dynamic, as you suggest, if there's a challenge response situation, that could be interesting. If you have a committee whose job is to come up with variations of this, yeah. Don't know if it's feasible, but sounds interesting.
I want to poll something here. I immediately also thought of Hugging Face. Who's addicted to the Hugging Face benchmarks in this conference? Just so I understand. You're not.
I don't know what that term means.
Hugging Face. Okay. I know you watch that pretty often. So what happens there is that you get internet points for being number one for the 5 minutes that you're number one, because you crammed a lot of, like you burned dollars on GPUs and kind of, you know, specifically wanted to beat the last week's top one on that table. It was popular for a while until people realized that targeting that doesn't produce good vibes when you use the model. It gives you models that are extremely good at being top of the leaderboard of Hugging Face. For the LLM, for the embeddings, it's still quality results. I think if we wanted to take something from this type of approach, it's the openness and the speed at which new models are ingested, because just the announcement of now it's the first, it generates its own interest in that community. There's its own dynamic.
Yeah, I would like to ask you, don't you see also a lot of potentials of things going the wrong ways that instead of the right way? Because, I mean, I think, or maybe like what I don't agree with you is like, it's not like, I mean, there are scientific communities who take care of these things of how we do code efficient. So it's not like it's an unscientific topic, it's just like it's outside kind of like the community here, so to say. So, I mean, or just like hearing by the some of the ideas, it could be also like you could have someone who just created a super optimize Julia code for KCG, but what are the implications for that? Are we going to just have to jump to the Julia? I mean, what are we optimizing there, or like, are there not so many levels of interest that we're going to also shift the conversation to which programming language is better, or what is the interface who is more most appropriate to it? So, I mean, this is just like a topic or idea to put. Yes, upfront. It could be also like be very harmful.
Yeah, I think it's a danger, absolutely. And again, I'm not going to try to have an answer to that. I think any effort of this type should try to get vague initial answers and iterate them. And I think the meta question that's really important is, do we accept, I think either there's only one possible consistent set of state of affairs. So either we accept that this is unfeasible and we just move on maybe, or if maybe there is a state of affairs for which you can believe there is a way to be semi-consistent and semi-okay with it, and we decide to move forward. I think that's a question I'd like to get an answer to.
I would note as well that alongside Hugging Face, another thing that might be worth taking a look at is the satisfiability solver community have been running stuff like this for a very long time, like SatComp and SMTComp, and they do a really good job of having like a very good, like it tends to tie in very nicely to developments and like standardization of like encoding formats for things, and they have a very good framework for committee runs it, how they come up with the various tests that get run and how things are reported in a kind of neutral way. So, I don't know what a website is, but SatComp and SMTComp are the Boolean satisfiability and then satisfiability modulo theory competitions that very much have this flavor and have been doing it successfully for a while.
Good, thanks.
Did you submit something there?
No, I just wanted to steer away a bit the conversation from the benchmarking. So there are other communities that have been doing this this more systematically, benching things and checking who's. And it's easy. So I don't know. We try to. We immediately got people worried, and people are saying, no, this is not the way you need to measure the performances of proof systems, because it's easy to. You're basically incentivizing people to cheat. Like I can make a SHA circuit that is completely under constraint, that is completely wrong, but it's going to pass the benchmark, and it's going to smoke everybody else. So that's not very fair. Or the other argument, I think was Mary Mallard that brought this up. She was saying it's easy to lower the security of your proof system. Like I put it at 5 bits of security, and I'm going to be much faster than everybody else. So that's why we were saying you need to submit a software artifact to bench, but you also need to submit a sort of specification of what you're doing. And I mean, this could be a book of 100 pages, or it could be like one page PDF, whatever. But you need to describe a little bit what you're building, and there has to be a human review of this. So you cannot just submit something on a website. We need to check that your sort of is reasonable what you submitted. So that's why there is a lot of manual effort that has to go into this.
Anyone else?
Okay, I also think that sometimes for me efficiency is also not everything. Like there's like functionalities issue, like, and maybe sometimes functionality schemes give you functionalities that we don't even value at a certain point. Like, for instance, I don't know, this has homomorphic commitments, and at some point, this was not relevant, and suddenly it becomes super relevant. And I sort of don't like a bit of like the efficiency obsession. If this, like, I think it's so complex, the comparison, that there should be like a lot of parameters on which things are compared.
Yeah, I hear that. I think, so some of those non-performance and non-security related features should maybe go into something like this. So I expect this not to be, what's the word, a comprehensive sort of, I'd be okay if there was, say, a bias towards efficiency and somewhat security, and maybe we don't account for additive homomorphism of polynomial commitments and so on and so forth. I agree that won't be perfect, so, but then again, the goal would be to have something that helps us understand the state of affairs some way.
I can add to this, there was an interesting conversation topping Hacker News a while ago about why is there no libraries for graphs. And the conversation went something like, there's so many ways to do graphs and apply them in so many different applications that as soon as you start going that path of what do we keep in the library, on the very first step, you ask yourself, well, are we emphasizing more this use or that use? And if it's a generic library, then the opinions you start making immediately affect very deeply the usefulness of your library. So we ended up in a situation where you don't just do, pip install graph and have the best available graph library in the world, because it really depends on what you want to use. If there was an obvious scheme or set of schemes where this is obviously what you need always, and you just pip install it or do something else with it, just bring it because everybody uses it, we would see it appear already. So we do have so many axes of comparisons that and different uses that it does create a lot of confusion. We might be able to solve it by separating by broad use cases and having this exact same approach on broad use cases. But I think the reason why the previous efforts haven't caught on as like the place to look was because of this variety of uses. Now it's crystallizing a bit more what can you use your knowledge proofs for, or just provable computation, verifiable computation. Then those areas are a bit more defined. It could be the time for that. So I want to thank you again for the talk.
Thank you.
And with that, if I remember correctly, that's it for now, right?